You want to buy your mom flowers, and the store has 3 kinds you can use to build a bouquet: daisies, tulips, and sunflowers. How many different types of bouquets can you create? Now, the trick in this question is that the question didn't specify the requirements for a bouquet, meaning you don't actually need all 3 types of flowers for it to count as a bouquet. So I could have, just daisies and tulips, or maybe I actually want one with just sunflowers. As long as there's flowers, it counts as a bouquet. So we actually have a couple different cases here. Case 1 is where you actually only use 1 flower, and that would be 3. So we have 3 flowers, and we're going to choose 1. And that's actually equal to 3, which in our case makes sense, because what we're saying is if we have 3 flowers, the number of ways we can pick just 1 flower is 3. That's reasonable. I can pick a tulip, I can pick a sunflower, or I can pick a daisy. Those are my only 3 options. Okay, case 2 is where I have 3 flowers, and I'm going to pick 2 of them. That is also equal to 3. And that makes sense because maybe I pick these 2, I pick these 2, or I pick these 2. That's still 3 options. And again, notice how the order doesn't matter because we're talking about bouquets with flowers. So the order and the arrangement of the bouquet doesn't matter as long as all the flowers are in there. And then the last case is 3 flowers choosing all 3 flowers, so they're all included in the bouquet, and that's actually 1 because there's only 1 way you can pick all of the items. Okay, so whenever we have different cases like this, we're going to add them together. So that's 3 plus 3 plus 1 equals 7. But what if this question was changed? So it was very easy for us to figure out the 3 different cases and that there is 7 possible bouquets. However, if the question was changed and there weren't only just 3 types of flowers, maybe there's 10 types of flowers or even 5 types of flowers, there's going to be an increase in the number of cases. And so that's a lot of work. So there is actually a much easier way to approach these types of questions. Consider the following. We've got 3 choose 3 plus 3 choose 2 plus 3 choose 1. So that's almost all of the possible combinations with 3 as our n value. The only one that we're actually missing is 3 choose 0, of course. Now, all of these, except for the 3 choose 0, were actually a part of so these ones were a part of the flower question, right? Choosing 3 flowers, choosing 2 flowers, choosing 1 flower. And this right here would theoretically be the case where you're picking no flowers. 3 flowers, but you're choosing 0 of them. If we do some simplification here, we get 3 choose 3 is 1, plus 3 choose 2 is 3, plus 3 choose 1 is 3, plus 3 choose 0 is 1. And that is equal to 8. When you have all of the combinations possible, given a certain total number of items, and you are adding them up, you can use the following formula. 2 to the power of n is equal to the addition of n choosing n plus n choosing the number right before it, all the way down until n choosing 0. So these are essentially the subsets of the larger group, right? Because you can choose all 3 of them, or maybe you're choosing a subset, which is 1 instead of all 3. And in this case, you're incorporating all of them. The reason that you can actually use this 2 to the power of n and why that actually makes sense is because for every single item, each item in a choosing question has the opportunity to either be inside or outside. So for example, with our daisies, our tulips, and our sunflowers, in each bouquet, each flower can either be a part of the bouquet or not. So each flower essentially is two choices, in or out. And 2 times 2 times 2 is 8, which of course is what we found over here. However, in our original question, our answer was 7. Why is that? Well, we do not want to incorporate this last option, 3 choose 0, because that would mean that we're picking none of the flowers, so we're not coming home with a bouquet. So a simpler way to do questions when you have all of the subsets, except for the last one, you can do 2 to the power of n minus 1. In general, if a question says that you can choose at least one item, you can use 2 to the power of n minus 1. If it doesn't say at least one, but you can still use all the possible subsets of, then you can just use 2 to the power of n.